The topic of this video will be the formation of halohydrins from alkenes. Halohydrins are compounds that have an alcohol and a halogen. We synthesize them by adding both a halogen and water to an alkene. This produces the halohydrin. This reaction is both stereospecific and regiospecific. It is stereospecific because the hydroxyl group and the halogen add anti. It is regiospecific because the hydroxyl group adds to the more substituted carbon. We can explain this by looking at the mechanism of this reaction. The first step of this mechanism looks a lot like the addition of halogens to alkenes. The double bond of the alkene attacks the halogen. This kicks off the other halogen as a leaving group, forming the halonium ion. However, instead of the halide that is formed opening up the halonium ion, water attacks. To form the protonated halohydrin. In the final step, another molecule of water deprotonates the protonated halohydrin. Now let's look at a specific example. If we treat this alkene with chlorine and water, we get the following product. Now let's look at the mechanism for this reaction. In the first step, the alkene attacks the halogen, kicking off the chloride leaving group. This forms the chloronium ion. Next, this chloronium ion is attacked by water. Just like we saw with the mercuric cyclic intermediate, there is a larger partial positive charge on the more substituted carbon of the chloronium ion, and a smaller partial positive charge on the less substituted carbon. Therefore, the water attacks the more substituted carbon, giving the protonated halohydrin intermediate. It is this step that determines the regiochemistry of the product. In the last step, water deprotonates to form the halohydrin. Now let's look at another example reaction that illustrates the stereospecificity of the formation of halohydrins. If we treat this alkene with bromine and water, we will get two products, a pair of enantiomers. In order to understand why we only get two of the possible four stereoisomers, we need to look at the mechanism of this reaction. In the first step, the alkene attacks bromine, kicking off the bromide leaving group and forming the bromonium ion. Now let's redraw this bromonium ion so we can better understand the stereochemistry that results when water attacks it. Water can attack the left carbon or the right carbon of the bromonium ion. Both of these possibilities are just as likely because both of these carbons are equally substituted. If water attacks the right carbon of the bromonium ion, we will get the following product. If water attacks the left carbon of the bromonium ion, we will get this intermediate. The final step is deprotonation by another molecule of water. Deprotonation of the left structure results in the left product. Deprotonation of the right structure results in the right product. In this way, we get these two enantiomers and not the other possible stereoisomer that could result from this reaction. And this is due to the stereospecificity of the mechanism of halohydrin formation.